In this video tutorial, we are going to build the personal finances application that you see on your screen. The app is written in Java and uses the libraries from MindFusion Pack for Java. When the user clicks on a date, the application shows a blank spreadsheet template where users can write their daily expenses. The app sums them, and if they are more than the daily allowance, shows the difference in red. When the user changes the date, the data from the previous date is saved in an XML file. When a date, for which an XML file has been saved, is clicked, its data is loaded again. We have implemented data validation for the cells with expenses. If the user tries to enter there anything but numbers, the edit is canceled. We start with an empty project using IntelliJ IDEA as the development IDE. There, you can see we have an empty JFrame and we have imported a few swing and AWT namespaces. We download MindFusion Pack for Java from the website, and once we extract the archive, we copy the JPack jar file to our project directory. Let's place it in a folder called libs. Then we right-click on the jar and select Add to Project. We can check from the menu Project Structure the tab Libraries to make sure the lib is there. We add now several class variables that we'll need for our project. We want to have global access to the worksheet and workbook of the spreadsheet, to the calendar, and the pie chart. We import the necessary namespaces. We also declare variables for the daily allowance, the current daily balance, and the date. All of those will be used throughout the project. We initialize the workbook and worksheet objects. We need a workbook view instance for our spreadsheet to render onto. Let's add the view to the content pane of the JFrame. If everything is correct, we should be able to see the spreadsheet. And here it is. Let's create now the two other controls, the calendar and the chart. We need a panel to hold them. They will be placed right to the spreadsheet, which takes all the remaining space after they've been added. We create the J panel and we create the calendar, which is declared as a class variable. It's important to give dimensions to the calendar because both it and the chart can stretch or shrink to use any space, so it's up to the developer to provide some guidelines. Let's add the chart now. We will use a pie chart, but there are numerous other options in the charting library. We set the preferred size for the chart as well, and we add it to the right panel where it takes all the available space. If we run the app now, we can see that the chart is indeed added. You can see the legend. Let's start customizing the chart first, so we can see a decent chart. Now we actually see an empty chart. We add a new method called createPieSeries, which receives as a parameter a list with double values. The method creates an instance of the PieSeries class. Note that charts are also present in the API of the spreadsheet. So in this particular project, it's worth paying attention that you are using the correct charting API. Then we check the class in the online documentation. As you see, the constructor of a PieSeries can have inner and outer labels, which can be null and data. Let's use our method now to add a series to our chart. We create it with some dumb data, and here it is. We can see now the chart, which is also interactive. Let's customize the chart now. We set its title and some margin so that the title does not stick to the rest of the chart. We change the background and allow the chart to be rotated and zoomed. We hide the legend and specify the type of labels to be rendered. Those will be the outer labels. Although we have specified the labels in the PieSeries, we also need to specify the type in the chart. Last but not least, we increase the size of the label font. Now, if we run the chart, we see that it looks indeed better. Now let's add some colors to our pie chart. The chart appearance is set by themes, and the theme uses the setSeriesFills method to specify a list with nested lists with the brushes. This is done so that charts with multiple series can have unique colors for each series as well. The pie chart uses a single series, but we still need to provide a list with brush lists. In our case, the nested list is just one. We assign a new charting theme to the pie chart and set its series fills using our new method. We also change the highlight stroke, which is the brush used for stroking the outline of each pie piece. The chart looks great now. Time to move to the calendar. We used the light theme as a theme for the calendar. We get the month settings field and use it to specify what we want to see the current date marked. The calendar object has fields for each view according to its type: month range settings, timetable settings, list view settings, and more. Let's get back to the spreadsheet now. We start to customize it. Let's add the title. You get a cell or ranges of cells from a spreadsheet with the getCells or getCellRanges methods. Then, in the get method, you specify as a string the cell or the cell range. So, we get the cells that we want to be used by the title and merge them. We want to style them, and for that, we get their iStyle object with the getStyle method. The iStyle interface defines a variety of methods for customizing the appearance of spreadsheet objects, columns, rows, cells, etc. As a rule, this is what you do to add data to a spreadsheet and style it. You get the cell or cell ranges and set their data. Then you get their style and customize the appearance. Now I am going to paste the code for the other cells in the header of the spreadsheet. Most of the code is the same as what we've just demonstrated. There are two new things, however. The first is specifying a formula as data to one of the cells. You do this by typing the cells and the operations among them. The other is formatting a numerical value. You use the setFormat method. When we select the cell with the formula, you can see the cells involved in the calculation. We add now conditional formatting to this cell that calculates the formula. The idea is that when the sum gets negative, it must show in red to warn the user. Conditional formats are set on the cell style using object instances from the iConditionalFormat interface. We set the condition to be regarding the cell value and the comparison operator to be less than. The border value with which we compare is set with the setFirst. If the comparison is between two values, you would use the setSecond method to specify the other one. The format also has style field, and there we specify how the cell looks when the condition is met. Yes, the text of the cell turns bold and red when the value is negative. Good. I paste again the code for the cells that describe the expenses. As you see, there is nothing special about them. The code for the last bottom cells on our spreadsheet includes using the sum function. It is listed, together with all available functions, in the reference for the library, which you can check online. Now, when we type in numbers, we can see they get summed and the current balance gets updated. So, what do we do if the user types in letters instead of numbers? Let's stop them by using data validation on those cells. We add a new method called validateNumberCell. There, we check if the newly typed data is an empty string, which means the user has deleted the cell contents. That's acceptable. We also check if the edit was done on one of the cells where the cost of expenses is expected to be written. Finally, we try to parse the number. We are going to call this method from the event handler of the worksheet cell changing event, which is a validation event. Events for the spreadsheet are handled by Workbook Listener, which uses a workbook adapter. Now, if we try to type in text, the edit is dismissed. Numbers are accepted. We can also delete the cell contents. Let's increase the size of the columns where we write the expenses. We use the getColumns method and specify the width of each column. Now let's update the pie chart every time the user types in new expenses. We will declare a method that gets the values of the cells that hold the sum of the three types of expenses and the sum for the current balance. There's nothing fancy about the code. We just get the data from the cells and try to parse it. If that's not possible, we assign 0 to the value. Then we create a new pie series with the parsed numbers and assign it to the chart. The method that created the pie series was discussed at the beginning of this tutorial. We need to handle the worksheet cell changed event, which is raised when the new data is entered, and in contrast to worksheet cell changing is not a validation event. In the event handler, we just call the update pie data method. And now, our chart gets updated every time the user enters a new expense. We have one more feature left to implement. Save and load the expenses sheet for the day when the user changes dates with the calendar. The new onDateClicked method saves the current workbook by using the Save to XML method from the Spreadsheet API. The name of the file follows a simple convention of converting the selected date to string. Remember, we had a class variable that keeps track of the current date. This is so because when the user clicks on the new date, the old date is not kept in the resource date event data. Once we've saved the old file, we try to load a file with name according to the newly selected date, which is given to us with the event data. If the file exists, we load it with the load_from_XML method. Note that when you do this, you need to get the worksheet from the newly loaded file. These are separate objects, and refreshing the workbook view does not refresh the worksheet. If the file does not exist, we clear the contents of all cells, which keep track of the expenses, and set the currently selected date. We also assign the current date variable to the newly selected date. The last thing to do is handle the dateClick event, so we can call the onDateClicked method every time the user clicks on a new date. We add a new calendar listener with a new calendar adapter, and we override the dateClick event. Let's check in the online documentation the event signature. Everything seems correct. So, now we expect changes to be saved every time we click on a new date. Let's see. Yes, here is the file. Let's try another date. The data from the previous file loads, and the data from the new date is saved as well. So, we've just finished this personal finances application built with the help of MindFusion libraries from the Pack for Java Swing. If you've made it so far in this video tutorial, thank you for watching, and thank you for your interest in MindFusion developer tools.